Good evening students, I am again here to let you know about the belt conveyors. It is one of the modes of continuous transportation in mines. There are very rare ways of transporting in the mines in continuous way. So, this is most effective way, the belt conveyors are the most effective way of continuous transportation in mines. Media, moving belt driven by head and drum, which is driven through gear mechanism by a motor or engine or hydraulic motor. Even hydraulic motor is not the prime mover, whereas motor and engines are the prime movers. So, hydraulic motor also needs power from either motor or engine, then only hydraulic motor works. So, it is preferred that motor and engines are used as prime mover directly on the conveyor belt system. Receives falling material at its tail end, that means at the normally the materials are received at tail end, which is at lower level than the head end, and head end is the place where the driving mechanism of the belt is connected. Most suitable for inclination below 30 degree, because it is very good for, it is a very good conveying system. 30 degrees and less angle for transportation. Commonly 38 degree is the angle of repose. So, we can't exceed in any case the angle of the belt with horizontal with horizon, we can't exceed more than 38 degree, that is a theoretical one. So, practically it should not go more than 30, maximum 32 degrees. So, that due to angle of repose the material does not roll down on the belt. These are the types of belt conveyors. This is primary types I have just mentioned, there are several other types, but troughing belt conveyor and plain conveyor means it is not ribbed, it is the belt is smooth, it is not ribbed. I will show the photographs, whereas flat belt conveyors are the rarely used conveyors for shorter distance, because there will be spillage of material on the from the sides. So, normally flat belt conveyors are not used, but troughing belt conveyors, this is one of the special type of conveyor profile, that is called pipe conveyor. Pipe conveyor means the troughing belt takes the shape of pipe in as soon as it leaves the receiving tail end. After that, because of hexagonal, I will show the photographs in next slides. These are the different parts of conveyor. The head end is the upper side, where head drive pulley is mentioned. The tail is the tail end pulley side, the lower side where the belt is receiving the material, and head end it is discharging the material. You can see a box type of shape shown on the right hand side of the head, on the right hand side of the head end, through which the material gets discharged. It is also shown by the green color arrow coming down. So, that is the discharge direction, whereas the tail end side there are some black patches, you can see the thick black patches. So, that is basically the rubber skirts which is protecting the material, falling material from top. The arrowhead is shown falling from top, and that is also written the transfer point, you can see on the right hand side, sorry, on the left hand side, tail end side. So, that is the transfer point. The belt is receiving the material from other discharge devices. The middle portion at the bottom is having a counterweight which is free to suspend and which is free to move up and down depending upon the tensions coming on the belt. So, that is called take up, and the suspension point is from the center of a pulley. The counterweight suspension point is from center of a pulley, which is known as take up pulley. You can see the belt, there are small rollers shown on the belt moving upward, shown by the green line upward along the belt. It is parallel to the direction is shown in green line parallel to the belt running. Similarly, the return side is shown with a green arrow coming towards left side on the return side of the belt. The belt on the upper side, which is the receiving and conveying side, is resting on, you can say, the small rollers which has been shown. So, those rollers are basically the troughing idlers that has been just shown symbolically, and the bottom rollers are the flat rollers, return rollers are there shown on the return side of the belt, on the both the sides of, you can say on both the sides of belt stretched parallel to the upper part of the belt moving up, and whatever is the there are two pulleys shown coming down with a parallel line of a belt. So, those two pulleys on the left and right hand side closer to each other just above the counterweight system, this deviation pulleys, and the pulley just there is no idler given just below the wrap of the belt. You can see on the right hand side just below the drive pulley there is shown snub pulley. So, snub pulley is just to it is basically snub pulley is just to increase the lap angle. Lap angle is the two contact points of the belt with the driving end. So, that lap angle is an obtuse angle, okay, not the acute angle, that can be seen by drawing a line with the contact points from the center. So, that is the snub pulley, and you can see the just before snub pulley and the drive and head pulley, you can see a small device fitted at the bottom, that is called the scrubbers. Scrubbers function is to scrap the stuck material, stuck particles from the belt due to wetness of the material, because after processing the material becomes wet and the wet particle gets attached to the belt. So, that needs cleaning. It is basically a brush kind of thing which removes the adhering particles with the outer side of the belt coming on return side. So, that the scrapped belt, I mean to sorry, the belt which is already cleaned because of scrubber, the scrubbed belt will be rolling over the return idlers and it will be not eating away the return idlers pad due to rubbing. This is called troughing idlers. This is a troughing idler is normally given on the running part of the belt. Running part of the belt rests on it. You can see idler roll are indicated by arrow marks, whereas the belt is also indicated by a thin line. Similarly, idler frame is shown from both the sides, which is holding with the deck of the belt. Deck of the belt means that it is a steel part. All these idler frames and decks are made of steel, which is holding the idlers with the bracket, that is also called the bracket, and center part is also holding the idlers from the bottom side. So, the idler angle with the horizontal is around that is called the troughing angle or trough angle, belt trough angle, that is normally 20 degree to around 40 degree depending upon the requirements. You can see the profile of material on the troughing idler above which the black color thick line is the belt. So, that is the belt above which the material bulk material is resting, you can see, and the belt is running longitudinally. This is just a section. Then return idler is shown at the bottom of that. It is a flat roller, you can see return roller is a flat roller above which the belt runs flatly on that. It is not troughed like on the top, which is the carrying side of the belt, and the empty belt which goes down goes over the return idlers and the belt is running in flat position. This is called conveyor system. That means, the jumble of so many conveyors making the head end of which is making the discharge point on the tail end of the other next onward conveyor, that is again taking the material from tail end to head end on the top. You can see the central belt. So, that is taking the material from tail end which is at lower level to the top level, and that is again making a discharge point. You can see a box, white color box, that is a discharge chute, that is making onward transfer of material on the tail end of the last belt, which are there are two belts on the left and right hand side. There will be a gate in between. That gate will be opened according to requirements of the transferring of material on either of the belts. Both the sides of belts are meant for different purposes. So, there will be a gate, switchover gate just at the discharge point or on the receiving point, before the receiving point of the last two bifurcated belts. This is a swing belt, this is used for stacking. You can see the rollers at the bottom, which is basically moving on a rail, which is the rail is installed on the top of the curve wall. So, it goes on swinging in arc shape, and that will be stacking the material in arc shape, so that more material comes than the straight line, because arc shape within the same space will be containing the more material because of its curvature than the straight stack. You can see the material how it is stacking on the by the swing conveyor, and it swings on the rail with the mounted wheel on the rail, and that mounted wheel is fabricated and attached to the conveyor, you can see. So, it goes on swinging, and then it is stacking on the arc shape of the apex of the stack will be arc shape, and it will be accommodating more of the material in comparison to straight line conveyor system, and this is easy also to swing. The circular wise, it is, I mean to say, on the circular path it can be swung in very easily, that is why it is given the circular path. The pipe conveyor is not by structure pipe, it is also a flat belt, but when it moves through a completely earlier we have seen the idler open on the upper side. Now, the same belt, when it is passed through the set of idlers, which is hexagonally fitted from all around, and the pipe passes through in between, then it will be getting folded as shown in the next. See, this is the hexagonal idlers, you can see. On the top also it is having the idlers are there, unlike the troughing idlers shown in the earlier diagram. So, these upper side idlers are causing the folding of the belt. The belt at the discharge and receiving the material from the previous belt, at that tail end side, it will be flat belt. It will be flat belt where it is receiving the material. It is on the common idlers, which is open from upper side, but as soon as it moves ahead, it will be guided through the hexagonal idlers shown like this, and it is covered from all the side. You can see the hexagonal is complete, it is not open from upper side, it is not open on the upper side. So, it will be turning the belt width to form a pipe. The advantage of this pipe conveyor is that there is absolutely no spillage, and its negotiability on the curve is very good. Here you will be seeing that below the skirts, the black color pads have been shown at the bottom portion of the conveyor where it is receiving the material. There will be impact idlers. Those impact idlers are having rubber coating, the rollers are having rubber coating from the rollers will be there, and it will be having rubber coating. So, rubber coating gives a cushioning effect to the falling material, and the belt passing between the falling material and the impact idlers will be not damaged because of falling materials from the top. That falling material is basically a rock. So, if the bottom idlers are with steel or any hard material, that will be impacting the belt directly against the hard material, and belt will be damaged. So, the bottom idlers are having rubber coated rollers, which are called the impact idlers. So, this is called the pipe conveyor, and when it reaches to the discharge point at the head and pulley side, there you will be finding head and drum side, there you will be finding again the hexagonal idlers will be removed. Instead of that, troughing idlers will start coming from increasing angle of 45 degree to 30 degree to 20 degree, and again it becomes flat at the discharging end. So, that it will be getting open, the belt will be getting open to discharge the material onward at the drive head side, drive head pulley side or drum side, drive head drum side. This is called the ribbed conveyors. You can see earlier we were looking, and whatever we have seen are the plain belts. So, here you can see the ribs are there on the belt. The advantage of such belt is that it can negotiate on higher inclination, even more than 35 degree, or even it will not allow the material to round all, but it is not advisable to run the belts, any of the rubber belts or any conveyor belt system for more than 32 degree to 30. If this kind of ribbed belts are used, maximum we can go up to 35-36 degree, not more than that. We cannot exceed the this angle of repose in any case, which is 38 degree. common, almost it is 38 degree for all kind of materials. Now, we can see the productivity calculation by thumb rule, capacity in tons per hour, 0.03 belt speed in feet per minute. Actually, these are the thumb rules given from by the old time engineers. So, it is in foot pound second system. So, it is just a thumb rule. You can follow this to calculate the belt conveyors capacity as shown by the calculation. It is nothing big. It is just conversion of foot pound second to, because these days we are measuring the material on the belt by running meters, not by foot pound second. So, I have all converted to the from foot pound second to MK system, that is meters, kgs and seconds. Okay. See, nothing big. 0.306 is 1 foot is 0.306 meters here. So, that is the way, and 2.2 is the conversion factor for 2.204 is the conversion factor, that means 2.2 pounds, 2.204 pound is 1 kg. So, I have just converted that to bring it to tons per hour. Productivity calculations, actually what we do, that was the thumb rule, but these days the people they follow more scientifically the how to calculate the more scientifically means you can say actual tons per hour has to be calculated. So, what we do, we stop the belt thrice when it is carrying the material, and at different times we calculate the we take out the materials from the belt for 1 meter length by measuring 1 meter length of the belt, and we measure it and divide it by 3 to know the material per meter the belt is carrying on an average, and we will see the belt speed by marking a mark and then calculating with stopwatch having a wireless set between the two, and they will be stopping the watch as soon as the mark on the belt passes two of the points, distant points. Difference of the stop this one this will be and whatever 2 marks are there on the belt will be measured. So, that will be giving you the belt speed per second with the stopwatch study, and by multiplying, see 1 meter belt is carrying how much. So, similarly in 1 hour how much belt length is covering the length, that can be calculated. So, that much meter covered in 1 hour multiplied by the 1 meter average material found by actual weighing, if you multiply that, that will be giving you the tons per hour at which the conveyor belt is running normally. Now, these are the different belt dimensions given here, and conveyor belt capacity by formula, how it is calculated. So, here you can see the different widths of the belt, and that is being, and the actual material profile is covering 70% of the width of the belt, not more than that, because at the falling at the receiving end of the belt from the previous conveyor or previous discharge chute, there are skirts means there are 2 sides blades which are guiding the material, falling material on the belt. So, 70% of the material, 70% of the width of the belt will be covered by the material profile on that, and accordingly this tons per hour has been found with the formula given here. Conveyor belt capacity by formula continued. Again you can see the different formula given. It is just basically the geometry and trigonometry, nothing different. So, you can understand the formula here, it has been just given for your reference on your ongoing exams. Determining conveyor belt width. So, these are the ways we decide about the conveyor belt width to be chosen. The conveyor belt width necessarily it is depending upon 2 factors. One is the how much tons per hour you want to carry, and second is that what is the speed of the belt. So, these 2 factors are deciding, but these are the basically thumb rules, these are the thumb rules. Okay. So, these thumb rules can be followed with respect to the diagrams previously given in the just previous slide. Uses of belt conveyors: if any continuous for transportation system or machines, e.g. surface miner for rowing, side casting or dumper loading. It is used for continuous miner, actually the miner word has been removed by mistake, it has been omitted. It is basically in any continuous miner system for transport or any transport system from the continuous miner while loading the dumper, that is these belts are used, though the belts are small. Bucket wheel excavator system for continuous cutting of material from mining phase and continuous transport henceforth to processing plant or dump yard, etc. It is belt conveyors are the necessary things for the bucket wheel excavators. Without that, bucket wheel excavator will not work effectively. See, this is the dumper is standing in the front, and back side there is a continuous miner. How it has extended the inbuilt conveyor system attached with the surface miner itself. The surface miner is having the attached integrated belt system. So, it is cutting the ground, moving ahead means opposite to the belt, and it is transferring the material to the reversing dumper. The dumper also goes on reversing with the speed of the surface miner going ahead on the opposite side of the belt. Okay. The other side is the moving direction, this side is conveyor belt moving. So, you can see how it is loading the dumper. This is another example of this continuous miner which is stacking material on the ground. So, continuous miner is operating on right hand side, on the right hand side diagram, and it is stacking the material on the left hand side. So, that is basically stacking, it is working as a continuous stacker by cutting the floor of the overbelt. The coal this continuous miner is used, this surface miner is used. Surface miner is basically used for on the floor of to cut the floor of the coal, because coal is a softer rock. So, this is a surface miner which is loading, and next is also surface miner. This is an in-pit crushing system. You can see the different belts, how it is functioning to segregate the material produced from crusher and to where the shovel is feeding, that is a hopper, crusher hopper. There the material is being fed to the jaw crusher, again it is coming to the smaller jaw crusher or a cone crusher, the secondary crusher which is, and the cone and jaw crushers are also working as secondary crushers after the primary crusher. And then after crushing to the size of 10 mm to 30 mm side, that 30 to 10 mm size is segregated by one belt, minus 10 mm size is segregated by another belt, and plus 30 mm, that means more than 30 mm particle. In mineral processing, plus 30 mm means it is more than 30 mm size. So, that is going as oversight back to the secondary crusher to get crushed further. This is the this entire setup of the mobile plant, mobile crushing plant and screening plant is used in open cast mining, where the things can be, I am going to say where the material can be received from different faces, nearby faces. This is the bucket wheel excavator diagram. On right hand side on at the middle portion, the bucket wheel is shown, the bucket direction, cutting direction has been shown, is skewed on the top side, and that is bucket wheel is rotating in anti-clockwise direction to cut the mining face. This is also used for softer rock like coal, lignite, etc. So, this is very commonly used in Lignite Corporation, Nivali Lignite Corporation. This is a Government of India enterprise which is in Tamil Nadu. This is another diagram of the bucket wheel excavator with different parts. You can see the bottom double hatched portion is the coal, upper portions are two overburden faces of the different kinds of rock. So, these can be selectively excavated by lowering or raising the wheel of the bucket wheel excavator, the cutting wheel of the bucket wheel excavator, and it is onward transferring the material continuously on the back side through a chute. You can see below the operator's cabin there is a conveyor belt, a small conveyor belt. So, that is feeding the material to one more conveyor belt which section has been shown only at, like a bowl at the bottom. So, that is a line conveyor. So, that is taking the material to processing plant, crusher, or else it is going to, if the reject is coming from top benches, then it is going to reject yard through the different gates made which are meant for diverting the material from one belt to other belt at the end receiving point, which is not shown here. This is the real diagram of the bucket wheel excavator. You can see on the left hand side the bucket wheel is cutting the mining face, the overburden, the white portion is overburden and bottom portion is the coal. So, the overburden is being cut now and it is going to the belt through a belt system. After the yellow color is the operating part of this bucket wheel excavator, and on that the bucket wheel booms can swing, the bucket wheel boom can swing in arc shape, and that arc shape will be going on cutting the face in arc shape only, and that will be continuously feeding the material through. After the bucket wheel there is a conveyor in red color shown. So, that is going to the central part of the bucket wheel excavator, that means above the yellow portion, and there it is being received by the falling material is received by the another belt system which has gone on right hand side, and that is ultimately discharging the material from the mining face continuously on a line conveyor which has been faintly shown in darkness. This is the bucket wheel excavator as a stacker. It goes on this cutting the material or from the stack or scooping the material from stack with the help of bucket wheel, rotating bucket wheel, and bucket wheel always rotates from bottom to upper side. So, that the material is lifted up and dropped on the belt as shown on the yellow horizontal part of the conveyor system, and that will be onward transferring to the tail end conveyor that other side. So, which or stacker conveyor, that is the right hand side small conveyor shown. So, that will be stacking the material on other side, transferring the material, and also the central part of the belt has been shown to receive the material for onward transfer to the material to the other end distant places, for taking the material to a distant destination after receiving the material from the bucket wheel system. See, this is a belt conveyor stacker. The material is coming from the inclined belt shown on the left hand side, and it is transferring the material to the bottom conveyor shown on the right hand side, and the right hand side the frame part shown, that is the discharge and where the person can stand to monitor the material falling, and he can also sample the material there for quality control. So, that at present the system is stacking the material on right hand side, the material is coal. Advantage of conveyor system, it is continuous transportation system, hence higher transportation productivity rate can be achieved. No pollution is taking place, because at the transfer point only dust is getting generated, and there we are sprinkling water spray, we are making water spray through pipes and nozzles. So, that is suppressing the dust. The dust generation points are centralized, unlike had it been transported by the dumpers throughout the road, the dust would have been generated and the dust concentration in the mine atmosphere could have gone high, but belt conveyor system avoids that kind of problem. No tire mounted transportation, so no dust. It can be covered also to arrest the dust generation at different transfer points with the nozzle spray, water spray system, etc. Advantage continued, it is most suitable for long distance transportation on hilly terrain and curvaceous terrains also. It is not negotiating on the sharp curve, but definitely it is negotiating on the obtuse angle. It can, if you see the plan of turning of a belt, it can definitely negotiate the transport of material on a curve up to the angle of 120 degree, even 110 degree up to that. So, after that it cannot form the most sharp turn. Okay. So, 120 degree and below is the most ideal turning, So, that is most ideal turning, that means 120 degree to 180 degree, you can say in between that it is the most ideal turning, and it can negotiate well with the transportation the running belt. Okay. It can be maintained easily and systematically in mechanized way. Along the belt conveyor frame, as it has been shown, that there is a path given for the people to move up and down with the tools and tackles, so that they can repair the belts or change the idlers, etc., if something is worn out. It is overhead transport system, so least interference with the lands and no degradation, land degradation takes place due to its installation. Occupy any space on the land much, and there is the least degradation of the land is there, and whereas in case of dumper transportation, for making the roads, the quite wider roads are there, maybe around 20 to 30 meters wider roads throughout the length of the road, that is occupying very much bigger space on the earth and surface, and that is definitely going to cause the more land degradation. Whereas in belt conveyor system there is no land degradation, there is negligible land degradation. Disadvantage, it is continuously connected segment wise in series. So, any belt, that means belts are in series, one after another belt is transferring the material to each other, next onward belt. So, any one belt goes down means it is paralyzing the whole system, the entire conveyor system is jeopardized. So, it is the biggest disadvantage with the system. Jamming of transfer chute is a common problem impacting the production. The chutes are getting jammed because of wetness of the material. You can say how it becomes wet through processing and also due to sprinkling of water for dust separation at the transfer points. So, this becomes wet and it is getting built up on the chute incline and it needs cleaning. The system deck needs frequent cleaning manually and some spillage of material takes place on the sides of the belt. Prone to fire, it is the most dangerous thing, it has to be prevented from fire, and because it is rubber, made of rubber, and it will be catching fire very easily and it will be spreading throughout the length of the belt because belt is running. So, the fire will be also going to the other parts of the belt and it will be causing a disaster. Suitable only for transporting graded materials smaller than 500 mm pieces. The wider belts can maximum transfer half a meter of pieces, not bigger than that, whereas the dumpers can carry the big boulders from blasted face. Thanks to all of you.